Okay, so now we're going to look at how to solve triangles that are not right triangles. So this triangle here is not a right triangle, but as you can see, I've broken it up into two right triangles. Okay, so the first law we're going to look at is the sine law, and this is the sine law in two different forms. I'm going to explain that as we go through here. Okay, so if you have a triangle ABC, and then you drop a perpendicular down from vertex B down to this edge AC, the side B here, at right angles, we can call that the height. Okay, it's the altitude of that triangle, the height. If we do that, we can then break this triangle up into two right triangles and try to get a relationship between the side lengths and the sines of the angles. Okay, so we're going to look at that now. So the first one on the left side, if we look at the triangle on the left, we know that sine of C equals opposite over hypotenuse, so h over a. And that means that h equals a sine capital C. Okay. On the right side, we see that sine of A equals h over c, side C. And now we can bring the c up, and so that we get h equals c sine A. So now we have two equations with h in it. We can compare them, since this equals h and this equals h in the same triangle. We can just get rid of the h's. Okay? And we've got this formula now. A sine C equals C sine A. And now you can try to get the same letters on the same sides. So we want all the C's with the C's, A's with the A's. And so to do that, we're going to divide both sides by A and divide both sides by C. And then we end up with this relationship. Sine of angle C over side C equals sine of angle A over side A. This could be written the other way around, right? So if you take the reciprocal of each side, it's the same, they're still equal. Okay? Now, if you were to do the same thing in this triangle by dropping a perpendicular from, say, side A over to angle A to side A, you would then get a relationship between angle B and angle C that looked identical to this. So you have then a double equality, or a double equation. So once you get that other relationship, you end up with what's called the sine law. In the sine law, you're only going to use two pieces at a time. So this is the law that relates them all. It shows you everything. But if you only need the outside two, that's okay, or these two, that's okay, or these two. You have to take a pair of them to use. Okay? So you need three pieces of info to solve these ones. And the other ones, you needed only two. Well, you had the right angle, so you needed three, but beyond the right angle, you needed two pieces of information. So now you have angle A, angle B, side B. In order to solve for one of them, you need three others. Okay? So let's take a look here. The situations where you would use the sine law, well, here's one. Okay, so say you had a triangle that looked like this, and you wanted to find, so you're given 7 and 13 as sides, and angle here is 27 degrees, and you wanted to find that angle. Well, you need to look at opposites. So angle A is opposite side A, and angle theta is opposite its corresponding side. So what you do here is you want to look for the angle, so you're going to start off with sine of theta. That's what you want to know, so write that down first. And then divided by the side opposite to it equals sine of 27 divided by the side opposite to it. So in order to use the sine law, you have to have opposite information that's given. Okay? And another one would be this. instead of the angle that's unknown, it's the side length. Well, then you can start with the side that's unknown first. So start with x divided by the sine of the angle opposite to it equals the other given information, 7 over sine 27. Okay? And then you go ahead and solve that by bringing the sine 86 up here and plug it into your calculator. Another situation would be this. You've been given, you want to find theta, okay? And you've been given this side length and these two angles. Or you want to find theta, x, and y. Okay, so you're given a side and the angles that's on either side of that side. Well, you can find the third angle by subtracting it from 180. That's not a problem. Okay? And you've got these equations now. Once you get that angle, you can solve for side y, or you can solve for side x. So either way. So if you're given information all around one side where it's a side and two angles, you should be able to solve for the rest of the triangle. So let's take a look at some examples here now. Okay. So this one here, solve for side A. You're given these two angles and you want to get side A. So, sorry, I covered up something that you're given. You're also given this side down here. Okay. So you need to then have the angle opposite to this side. Is that possible? Yes, it is. You subtract these two from 180. Okay? So angle B is 180 minus 57 minus 29 and gives you 94. So now you've got the angle opposite this side and you've got the angle opposite to the side that you want. Okay? So start off with what you want. You want A, so A divided by sine of A equals B, which is that divided by sine of B. Just plug in what you know. Okay? And then you bring that sine of 29 up here, right? So it's divided over here, so it's going to be multiplied over there. And you plug that all into your calculator, and you should get 6.37 meters approximately for side A. Okay? Now, another example right here. Okay, again, you're given two angles and a side that's down here. Can you solve this? Well, you can definitely find this third angle. Now you have an angle and a side opposite to it, but do you have this angle? Not yet, but you can calculate it. Okay, very easy to do. Now you can go ahead and solve for side A. So A equals sine A over A, or A over sine A, and B over equals B over sine B. Plug that all in. Do the algebra, and you get 5.65 centimeters. Okay. Another example right here. Given two sides, you got an angle opposite a side. Okay, you want to find angle C in this one. So this one here. So this is where you're going to use the inverse or the sine -1 on your calculator. So it's this relationship that you're going to use. Sine C over C equals sine B over B. Plug in the numbers, and you've got this now. So that will give you sine of C. Now you do this to about 4 decimal places to make it the most accurate. It gets the angle to about 1 decimal place. Okay, and then you do sine inverse of that, and it gives you an angle of approximately 83.1 degrees. These triangles are not to scale, so they're just a diagram for you to go by. Okay. Another one. Okay. So you want to find A first in this one. So to solve for B, you're going to need to find angle A first. Okay? So you've got an angle here and a side opposite to it. You can now find this angle because you have the opposite side. So using the sine law. Once you've got this angle, then you can use these two angles to find angle B. Okay? So, sine of A first, over side A, sine C over side C. Plug in the numbers, put in your calculator and give it a shot, and then do sine inverse of that. See, often I just keep that in my memory, or I keep it as the last calculation in my calculator, and then I just do inverse sine of that number, and it gives me the angle very accurately. Okay, so the angle A is set 27.2 degrees. We want angle B. So angle B is going to be 180 minus the two two known angles. So that's going to be 70.9. Okay, so that's it for the sine law.